Okay, in number 9b, it says which graph of y equals 2x minus 6. So which is the graph for the following? Well, 2 to the power of x being our exponent means we're going to have an exponential function. 1 is linear, 2 is quadratic, so it's definitely not either one of those. Now this minus 6 is a shift of down 6. This graph moves up, this graph moves down. So I'm going to go with option 3. You could also double check in your calculator. So I could go into my y equals, and I can type in 2 to the power of x minus 6, go to my graph, and take a look, and it looks like we have a match. Okay. Now in number 10a, it says given the parent function of y equals 3x, describe the shift in the graph. This plus 2 means that our graph is going to shift up 2. So the parent graph, y equals 3x, will shift up 2 units. Now, if you weren't sure about that, you could go into your y equals. I'm going to graph just the first function, the y equals 3 to the power of x. Take a look at the graph. Then we're going to compare it to the second function. But I'm going to graph it in the second line here. So we have 3 to the power of x plus 2. So my first function is there. I look at the second function, and it looks like each point moves up 2. Okay, in number 10b, given the parent function, y equals 4x, describe the shift of the graph. Well, two things happen here. We have a minus 6 in our exponent, and then we have a minus 3. This minus 3, like this plus 2, this one is going to go 3 units down. This minus 6 we need to be careful for. It's not left 6, it's to the right 6. And then if you're not sure, again, you can graph our parent function first, y equals 4 to the power of x. Then once we take a look at that graph, we could graph our second one and compare the two. We have 4 to the power of x minus 6 minus 3. Take a look at the graph. We'll definitely move down. And look how far over this goes now to the right. Okay, so the parent function, or the parent graph, y equals 4 to the power of x, will shift right 6 and down 3. Okay. In number 11, it says the number of acres of oak trees in Oak Grove Park was decreasing each year due to a bug infestation. The table below shows how many acres of trees were in the park over a 5-year period. Determine the function that best represents the data. Well, I'm going to take a look at my options here because they all look very different. A is linear, B is quadratic, C we have a cube, and then D is exponential. So if I take a look at my y's, they are all decreasing, but are they increasing by a first difference? This would have to be a minus 300, and then 700 minus 300 is 400, not 490. So there isn't a first difference. Okay, so the difference between our 1,000 to 7,000 has a difference of 300. Then we can check 700 minus 490 has a difference of 210. Then let's see, 490 to 343 is 147. Let's see if they have the same second difference. 300 to 210 is 90. 210 to 147 is not 90. Okay, so this was a 90. This was 63. So there isn't a second difference, so it is not quadratic. When I look at D, though, I notice that it starts at 1,000. We know in an exponential function that 0 is our start, so A is our initial amount, which is 1,000. I'm going to see if these work with, let's see, 1,000 times 0.7 is 700. 700 times 0.7 is 490. 490 times 0.7 is 343. So I'm going to go with D being the correct option. If you really even want to double check, we can enter this function into the calculator, as you could check any of these 4 functions in the calculator with your table. Just another method here. If I type this in and I go to my table, I can compare my values. 0, 1,000, 1, 700, 2, 490, 3, 343, 4, 240, and then 5, about 168. So D is definitely our correct option.